Hi, this is Coffee Compiler Club. It's the day before Christmas, so I'm not expecting a huge meeting. Anything to do with compilers and language runtimes and garbage collection and typing systems and nil and not the nil and everything to do with language implementations. It's all fair game. You're being recorded live. Your video will show up on YouTube within an hour or a day or whenever Christmas lets me. If you don't like that, bail out now. Everyone else has heard this is Bindu. I can't necessarily pronounce your name. Open mic, I reserve the right to moderate, never had to do it. It's all good. So I think with that, and that's it, that's the spiel. I do it every time for like 10 seconds. So Bindu, why don't you give us a 30-second introduction, including how to pronounce your name?
Hi, sure. My name is Dibyendu. I think you pronounced it correctly, so it's fine. So yeah, I mean, I'm not, I'm just a novice when it comes to compilers, but I've been working on as a hobby, extending a language called Lua. I don't know if you guys have heard of Lua.
Yeah, Lua we know of. Yep.
So it's a very small. So
throw
it's a
your
very
link into the chat or the Google Docs.
Sure,
I'll find it. Throw it in while you're talking.
So it's a Lua is a very small scripting language. So just if you know about Lua, then great. If not, it's somewhat like Python, but you can think of it like it's a very cut down version of Python. So I'll post the link here. So that's my project. So basically, I've been I started in 2015 actually. And originally, I was looking at enhancing Lua to use in a system as a scripting language, embedded scripting. So it was like my original idea was that there would be a business application where users would be allowed to script stuff inside the application.
Let's do Visual Basic.
Yeah, well, except Visual Basic is hard to embed in C++, say, code, right? So that was the idea, but that project never really went anywhere. So in the end, I just do it as a hobby at the moment. So I've been trying to add some a JIT backend. So I'm using, there's a project by a GCC developer called MIR. Basically, it's a very small JIT engine which can target different platforms, and it's got C front end. So you can either write directly to the IR it supports, or you can write emit C code and ask it to compile that. So the way I'm doing it right now is I'm producing C code from the scripting code and then using the mere JIT engine to convert to machine code. And originally I used LLVM. Then I tried GCC JIT as well. I tried Eclipse OMR, JIT engine. I tried many JIT engines. Essentially, the problem is that Lua is a very small language, and the situation was that the Lua code is like 200K and the JIT engine is like 10 gigabytes,
Yeah.
So 10 megabytes or 10 megabytes. So that doesn't really make sense. In the Lua world, nobody is interested in a JIT engine that's that humongous.
Yep.
So that's the problem. And Lua JIT is a very famous implementation of a JIT for scripting languages. I don't know if you guys know about it, but it's like a tracing JIT. And it's very small. It's like 500K. And it achieves performance like similar to, say, Java in a scripting language, which is extremely amazing stuff. But Lua JIT basically is kind of unreadable code. Like, only the guy who writes it can read it. So
this sounds very familiar.
It sounds just like the Java JIT.
Yes. Well, yes.
Well, Oracle has maintained a team for the last decade that's been able to make modifications and improvements. So I claim I'm not alone in being able to read it.
Yeah, I guess it's the hardest thing when your code is such that nobody else can maintain it, right?
I claim it started out looking pretty clean and pretty simple, but
Right. So
What is that?
anyway, so Lua JIT is like on, you literally need to invest years to understand that code. So therefore, my code is much simpler. It's a method level JIT, and I use type annotations, gradual typing for improving the performance of the generated code. So I can, for example, so the way Lua works is Lua is the VM, it converts to bytecode and executes in a VM of its own. And the VM is very small, and it generates bytecodes as it parses. So it's designed to be extremely memory efficient. Like, it doesn't even create an AST or anything like that. It just uses the C stack to parse.
The JavaScript implementation start this way. Yeah.
Yeah, and it's very efficient in terms of generating bytecodes. But then if you want to enhance the bytecodes and add type information, that's how I originally started messing with the Lua parser. It's quite difficult because of the way the parser works. So I recently started about a couple of years ago a new project where I'm doing a traditional convert to AST, and then from AST to an intermediate representation.
ASTs don't have to be traditional. I don't ever convert to an AST.
I know. So I wasn't aware of your approach until, I started listening to your talks, on this series. And that's why, so I wanted to understand that a lot more, but just to give you some background. So what I've done is I've kind of got a very simple, it produces AST, then converts to an intermediate representation. And then I use this I generate C code from there, and then I use this mir JIT backend to generate machine code. And it can all happen on the fly. And you can build the whole thing in seconds. Like, that's the thing about Lua, is that it's very small. And so with this JIT engine, it's still very small. Like, it's a megabyte in size, I think, after compiling everything. And it compiles in seconds, right? You can build the whole thing in seconds. But the problem, of course, is that you have to annotate with types, and that's something that Lua developers don't do, right? So they don't like that. So I'm looking to firstly add type inference to see if I can get away from having to force users to put types in.
Right.
What about kind of stochastic type analysis, or just basically, if it's always fill in the blank type, just assume it is, and then so build anywhere you link into that method, just have two entry points. One is the generic, I have no idea, and the other is I'm going to assume certain types.
It's the JavaScript thing, because they have no types in the language.
Yeah.
People mostly use the same types, but accidentally they get big int when they didn't mean to, and they don't care, and they don't know, and they're not paying attention, or they mix strings and ints and whatever fuck, they don't care.
Because the last thing you want to do is change the language.
Right. Yeah. No, that'll chase everyone off. So don't
because
do
that loses 100% of the user base minus you.
Yeah. No.
That's
so you
right,
put in
yeah.
you put in tests in the JITted code to say this is the thing that I think I want it to be, and if it's not, I go slow back to the interpreter. You go, and if it is, then now you've added the type. And then wherever you need to put type tests in, from there you can flow the types forward in a forward flow propagation of your types to, be able to JIT better code, or tell Mir how to JIT better code or whatever.
Yeah, and I've been thinking that why hasn't something like JavaScript, the effort that's been put into JavaScript, why hasn't that same thing happened in Lua? And I think the problem with Lua is that Lua doesn't have an object type. Like JavaScript still has a prototype-based object type.
You can ask the question, what is this type?
Yes,
yeah, but
in Lua you can't.
You're fundamentally asking the wrong question, though. There's only one reason anyone puts any effort into JavaScript. And it is because by far, probably by a factor of 100x, maybe 1000x now, it is the most commonly executing language. So if you improve its performance 1%, you actually save more power than Brazil uses in a year, right? Like it's such a fundamentally huge thing. Google actually makes more money by spending billions on optimizing V8 because they get to show ads faster, right? Like it's that simple. It's so Lua has 1,000 users and JavaScript has 8 billion. It's just a fundamentally different statistical model.
I got more than 1,000 users. But you're
talking,
right, it's off JavaScript by orders of magnitude.
Yeah, I mean, nothing comes close to JavaScript in terms of its widespread use, other than compiled form of C, because it's what's sitting under most.
But the techniques they use in JavaScript, you know, for example, you specialize because at least you have an object type, so you can specialize. With Lua, it's difficult because you don't have an object type.
So there's
What
no.
I was trying to get at fundamentally is it's not a technical question. The fundamental level of investment is definitely not a technical question.
Yeah, I don't think he's worried about the investment. It's his own time. I heard him say it. He's having a good time. So, you know, same as me, right? No one's paying me. So no, the question, I have a question about Lua. You really can't look at a random pile of bits and tell that it's intended to be an int.
So yeah, so there in the language itself, values are have types, but there are only a few types, right? So you have integer, you have number. Number is like a double, and you have something called a closure, which is like a function.
Yeah.
So functions are basically values, like somewhat like, and you have only one aggregate structure called table. Table is like a associative map array combination, right?
Okay.
And like then Python. Other than that, you can have native types, native objects, which are like called user data objects. So they are basically written in C.
And if you make a
you can provide, you can provide ways to access, well, make method calls on those native objects.
So so now if I take a Lua thing and I don't know what thing it is, and I hand it to a foreign function, can that foreign function decipher by looking at the thing that he's talking about an int or a double or a function?
So yeah, so it depends, right? If you pass the user data object, it's a blob of memory, right? So now it's up to you how you interpret that.
Okay.
So you got to keep track of what type it is yourself.
Okay, so you keeping track of what type would be the Lua JIT or the Lua VM. Somebody knows.
No, for the user data types, the Lua VM doesn't.
We're going the wrong way here.
Treats it like.
Hang on. We're going the wrong way. I'm going from Lua to native C code, passing in a Lua int, or a Lua double, a number.
Yeah, that's possible. Yeah.
Now
so you have explicit API for that.
The question is. Yeah. On the receiving end, can I tell the difference between an int and a double?
Yeah. So you can. So every value in Lua has got a type, right? So Lua, the way it works is that it's got a stack, which is like a heap. It uses the heap as a heap structure as a stack, right? So it's not the native C stack.
Yeah.
And in there, every value on the stack is like 16 bytes. Slot. There's a type and there's the value itself, and the value can be either an integer, floating point, or a pointer. Pointer is like
when it calls your native code, what does it do? Does it pass?
Well, if you pass, you have to pass both. Can't we just pass both, and you'll get the type?
So when you're interfacing with the native code in Lua, what you do is the Lua native interface exposes the stack to you. So you have to use the push and pop methodology. So essentially,
so you can
that's the way the garbage collection works.
Right. So you can say to Lua, what's the type of the top thing on the stack?
That's right. Yeah.
Yeah. Okay. All right. So that's all you need.
Right. Yep.
This is the 99%, 95% performance question. I'm talking about an int, or I'm not.
Yes, but the problem is, of course, that in the Lua VM, so like you are adding two values, then the code like says, is this an int? Is the other guy an int? Then I will add as an. But obviously that kills your performance, right? Because you just want to be able to add them without doing those checks.
Slow down, back up, slow down.
Yeah.
So when it's time to JIT, and you draw the line between I'm running interpreted, I'm running JITted, I'm making a cross call to the JITted code. somewhere in there, you want to start asking the question, am I talking about ints so far? I've only ever seen ints. Then I take a wad of code, however much I can deal with at a time, that I've said on input, I've tested all the types to be what I'm hoping there are. And then in this code, I know that those are the types. So I no longer ask that question anymore. So the JITted code has to ask the same question, however it's done. There are a lot of ways to do this. He has to ask the same question as the interpreter to begin with. But between the bytecodes, as he stacks more and more and more, he never has to ask the question again.
Right.
So you need to pick a region of code that's hot, has a lot of performance time spent, and ask those questions outside of that region. So the JIT needs to have the hot loop plus all its inlines and one layer around it. And then he asks the questions before he hits the hot loop. And then in the hot loop, he's got all the right questions asked already. He doesn't make any calls in the interpreter except to bail out and give up. Like, I can't handle you now, you go slow. But if you're going fast, you ask once in the beginning, you're hot in the middle, you never go bail out. And then when you're done, you exit back to the interpreter, you don't care. Maybe you go back to more JITted code, maybe you dump the interpreter a little bit and go back out. But the number one thing is to get hot loop where you ask the questions outside of the loop.
Right.
So now you profile.
Because there's nothing expensive about asking the interpreter, is that an int? If you do it once for each parameter.
Yeah.
If you have to do it once for each parameter when you're inside the loop, you're screwed.
That's when you suck. Yeah.
So that's what I call a preamble, right? When you JIT, you basically have the entry point where if the types are guaranteed to be int, that's your main code. You create a preamble, which falls into the main code, right? And the preamble is responsible for saying, is it actually an int? If it's not, let's jump back to interpreted mode. Is that actually a string? If it's not, let's jump back to interpreted mode. And once you check everything, then you just fall in to the code that's already built. Fall in, jump in, call in, whatever MER supports.
Sure. So the one challenge is, that in when you call a function in Lua, that function's types are not known, because
but you
don't declare functions, right? Only when you call the function, then you know.
That's not the issue.
But you do know them because you chose to know them, right?
Yeah.
So the first thing you did is every time that function was called, you collected the type information at that point. And then you said, okay, this function gets called more than twice, more than 10,000 times, whatever. And every time the type has been int. So I'm going to generate code that assumes it's int. I'm going to put a preamble in front of it that checks it's int. And then instead of interpreting that code, I'm going to jump to the preamble at that point. And now you have two things. You have the JITted code for that method, but you also have a reusable piece of code that assumes that it's int. So the next time you JIT something else and its types are already checked, it can jump to the already checked code instead of checking again.
No, I get that. So that's like specializing the method or the function based on the input types, right? And assuming that most often you'll be called with the same types, right? But I'm talking about the inside the JITted code. Every time I call somebody else,
don't do that.
I don't know what the type
I get
is.
It. No, when you call somebody else, you know your types.
I know my types. I know what I'm calling them with, but what I don't know is what they're going to return to me.
Okay. Right. So the number one answer here is don't do that in hot code. When you call out to somebody else you've profiled, you put the profiling interpreter. When you call from hot code to hot code, the hot code on the other side is going to get JITted as well, and it'll tell you what the return type is going to be. So
you may have to JIT it. You may have to JIT it 10 times for 10 different patterns, right? So sometimes it returns a string, then you build something there, and then sometimes it returns an int. You might build a separate one for that. The point is, if you know the outputs based on the inputs, you can select from that library of
I think there's an easier answer here, and that's simply to inline. If I'm in hot code and I'm making a function call in hot code, the code I'm calling is just as hot. So you inline it.
Yeah, and that's what Lua JIT does. So because it uses tracing JIT, so
Yeah,
it traces into the called
Yep.
method
Yeah,
or
exactly.
function.
And you want to do the same thing. You don't have to be a tracing JIT. I do method JITs, but I inline all calls to hot code. From hot code to hot code, you call when you inline. So the real story eventually becomes inlining heuristics make a big deal, because you do have borders where you have to quit because it's just too big or it's edgy. It's a little bit hot, a little not hot, fuzzy wuzzy. You get all these border cases. Now you have to decide, if I call off to a function that I don't know that it's JITted and he doesn't have a known return, I have to check his return when he comes back with what I hope it is. I can do that. But if it's not, then I'm going to bail out. And if that happens too often, you end up with, just as Cameron says, you get a couple different variations of, here's a guy that's calling hot to this guy, and if he returns a string, I'm over here. Or if he returns an int, I go over there. Whatever. You can screw around and get a couple different variations. But that's like incremental improvement. The number one step to do is look for regions of hot code where you can successfully inline everybody, type check the whole shebang, all inlines included.
Because very, very little hot code is dynamic.
Yeah, exactly.
I guess that's the argument I would make. It's not always
Yep.
true, but you should use that as your opening
Yep.
assumption.
Yeah. And it's, if you get all the hot code that is not dynamic, you will be hitting the 99% case right there.
Not just that, your next biggest thing to optimize after that will be the obvious dynamic case. So like nail the stuff that's not dynamic first, and then it should leave you with a good target.
Yeah, disappear off the profiles. Yeah.
Right. Yeah, makes sense.
So Cliff, the reason you don't use an AST is because your language is already lower level than most IRs.
There was something special about.
I started with Java bytecodes. They're all
I've been reading up and also listening to your talks, and I guess what I wasn't aware of and I hadn't seen before is everything I've seen before, like LLVM or every other implementation. They always have a linear IR. You have AST before that, and then you have the CFG separate structure, and the data flow analysis is done on separate structures. Whereas what you've done is you've kind of said, okay, let's start building SSA data flow in everything in the same data model, right?
Yeah, I did this in grad school. Read whatever language, build SSA directly, never come back out of SSA. It's only ever SSA.
Not only that, you're also including all the data flow analysis structures, which traditionally people just do as separate passes, right? They build those and discard them.
Right. I do not. Right. All the classic data flows are not built for me as a classic data flow. You can do them that way, but the natural, obvious thing to do, if I'm picking up York, is to run them on the graph IR directly. And now I can't find York in my new world order for doing things here. Here he is. Fine. Okay. Yeah. And you don't need the data structures, and this turns into less code volume, less data structure usage, less memory consumption, and a lot more compile speed. So it's both faster and simpler. Like it's some people claim it's semantically more difficult than understanding a single pass that just does CSC or just does loop invariant motion or whatever you're going to do. But I have found that, or at least for me, it feels extremely simple to do what amounts to graph rewriting rules, peephole analysis, graph rewriting rules. I look at a small region of graph, decide I know something about that small region, and I update it in place. That counts for dead code elimination, CSC analysis, all your constant folding things and multiply by 1 and add of 0 and canonicalization of addressing expressions where all your small constants fold up and turn into a nice format for your x86 addressing modes. All your repeated tests, like Java's full of nil checks, and all the repeated nil checks fold up this way. There's a bajillion of them that all happen as little tiny graph rewrite rules. Each rule independently is obviously correct and easy to understand.
But that's easy when your level of optimization is congruent with your level of node. If your nodes are naturally too big, it's just much harder to do.
Again, I'll claim no.
I'm not arguing against what you're doing. I think it's perfectly fit.
No. So maybe we have to talk what big nodes mean. There are certainly semantically big nodes in the graph where people throw in intrinsics, and they do intrinsic shit, like array copy as a whole node, which optimizes with new array optimization as a whole node. And those all become simple graph rewrite rules as well for doing all kinds of optimizations there.
Right, but it's kind of like, you know, look at the, there's some good blogs. I don't have any links to them off the top of my head, but I think LLVM, for example, they have a high level IR, which is the LLVM IR. Then they have a low level IR, which is kind of just one step away from assembly. And then they recently introduced an MLIR.
Mid-level,
Right, so they've got like 3 different IRs, and above the high level you have source code and AST, and below the low level you have assembly.
Right,
so
and I have
like,
one.
Right.
There's the source, then there's the IR, and usually the
what
IR
I'm saying is that there are reasons, there are legitimate reasons for
I hear
not
you.
having just one.
The only thing that I find somewhat difficult in the IR I have is doing whole loop transformations where you're blocking loops for like array reference reordering. So straightforwardly doing loop invariant code motion is totally fine. I restructure the loops for range check elimination. That one gets a little obnoxious. And that's about as obnoxious as it gets. That's where I have to take a loop body and I have to clone a prefix and a postfix and give them iteration counts based on what I think they might overflow or underflow. Plus, it gives me a chance to remove null checks and some other tests out of the core loop body. And then I unroll the core loop body by powers of 2.
But the benefit of an AST is that, you know, a single AST node might correspond to 10,000 low-level IR nodes.
I hear you. And that's exactly why I didn't do that. So the only reason to do that is because you're also then transforming at that scale. And I didn't ever find a use case for that scale. The loops are one where that would have been convenient. If I had a loop, I wanted to clone it by making a clone of just a single loop node that I had 3 copies and I declared one pre and one post and they did separate things. That might have been a little easier than what I ended up doing.
But you know, I think the reason you didn't need it is because you are only using this technology to JIT compile pieces of code. But imagine if you had to convert from Java source code, all of the original source code, which millions of lines of code, would it still be economical to convert everything into this graph?
I claim that that's sort of an unrelated question. How hard is it to parse Java code at all? And what do you do to make it, you know, correct? So I haven't looked hard at what the current LL1, LALR, whatever the Java version is. Usually these things have horrific semantic analysis that has to follow before you have known semantics. And in that case, I think you do whatever's convenient to get your semantics known.
It's got some ambiguity because of lambdas, but other than that, it's LALR1.
Okay, so minus lambdas, it's still LAR.
I'm not thinking of the complexity of parsing it, which is probably the trivial part. I'm just saying at the moment, what happens is that the Java code gets compiled to bytecode, right? And so all of the majority of the code has been compiled already to bytecode.
Right.
And when we are JITting, we are only JITting parts of that, right? But here, when we are going from source to the actual target, and if your target was a sea of nodes, like you have in your graph IR, it's going to be an explosion in terms of the memory usage and everything else.
That is not. You have no way to assert that is true or false.
No, because I haven't implemented, so I don't know.
Right. And I have, and I've stared at these things for a while. I've certainly gone from C straight to SSA form.
So here's a question, Cliff. Is your is your sea of nodes, are your nodes higher or lower level or identical level to Java bytecode?
There are, on average, this is not always the case. I would say on average, there are lower level. On the other hand, I carry
but
all my
by a constant factor, if you will, 2.3 or 1.7.
I've done this math. It's been a while. Yeah, there's an average blow up from bytecode to node. Now, right. the thing that goes straight to performance here is how big are the nodes? And then drop all the extra semantic info, like the tables for exceptions and other class constant shit, constant pool goes away and the like. So if you look at a class file and you look at a sea of nodes representation for the semantics of what's in a class file, the two are within a small constant factor of each other. And I don't know what that number is, but they're not hugely different.
And I think you basically just explained why it makes a lot of sense for you to drop directly to your sea of nodes.
From bytecodes, it makes a lot of sense.
Exactly.
Yeah, in my opinion, the AST is too much of a high level, and the low level is too much of a low level. That's why you need, at least for LLVM, you need another level of representation that still maintains the semantic of the high level in order to translate it more efficiently into the low level of representation. And that's why most of the languages has their own intermittent representation between the object-oriented and the low level in order to more efficiently translate between them. And that's where MLIR come up.
See, I started out with this notion. Oh, here's a guy I haven't seen in a while. I think he asked and didn't show. Okay, fine. So I started out with, I'm just going to run Java bytecodes, which are pretty low level. Then we discovered that, generics came along and there was a lot of information that was thrown away. And had there been another IR concept in the middle that kept the generic info, I would have taken it. Instead, I had to rediscover it. And so, the fact that I could 90%, 95% rediscover it told me that I didn't need another version of an IR. I could have held on to that IR had it been available at the bytecode level. I would have just moved it over to the graph IR and had those types. The graph IR you get is strongly typed. And in most cases, it's much stronger typed than the Java code. I discover everything that you have in the Java code plus a whole lot more, typically. And then there's a few places where I miss because generics dropped too much shit on the floor. But yeah, I claim I got there because it was easy to do all the analysis to discover all those high-level types, and it was easy to represent them in the IR. So the IR holds on to those high-level types. It has them all. I don't need another higher-level IR to hold on to the higher-level typing info. I don't have high-level structure so convenient as an AST for loop transformations. That one I can agree with. Things like if-then else's around or switches around instance of tables and shit like that, I have all that information. I discover the loops, and I form them in the IR that are both simultaneously a low-level hook and a single node, which represents the head of a loop. So I can easily find the loop body, but I have the loop body as a shattered piece.
The other thing I would say, though, is that generally optimizations are very hard to do with high-level structures.
There's a class you do at the high level and a class.
It's not right. Yeah. It's not uniformly true, but what I'd say is that in my experience, you relatively rarely find optimizations.
Yeah, and there's another. Okay, so here now that you said that, I'll bring up the other one. Okay,
I was going to give the pro though.
Okay.
It's very, very difficult to produce good error messages from low-level nodes.
Oh, I wouldn't do my semantic analysis for error messages there. No.
And that's where AST is great.
Oh, I see. Good. I'm doing them in the parser at the time that I.
Right. I mean, if it's a syntactic.
No. I get my semantic error there too. Let me restate that carefully. The parser I'm doing now hooks all the places where semantic knowledge is discovered and puts the hook into the node. And the hook is nothing more than a pointer into the source code. It's literally, a 4-byte pointer plus or minus whatever it takes to represent things. Then if the semantic analysis blows up, I have a point in the source code where I'm going to complain at you about. When I did this in C code long ago, I didn't deal much with error code, so I don't know. I took syntax errors from the hacked up C parser and didn't do many semantic error things. So yeah, I don't know about that one.
Your new language is fundamentally different from, say, Java, in the sense that in Java, you were working with bytecodes, right? So somebody else had already converted to bytecodes. And the representation you were working on was from bytecodes, build a sea of nodes and start from there.
Yeah.
Whereas here, you're converting from source code to the sea of nodes.
Like
so
I said, I've done
now
it
if your source was 1,000,000 lines.
Yeah, I've done it from source before. Oh, the 1,000,000 lines doesn't matter.
It's going to create a huge memory structure, no?
Same as an AST. There's no more, no less than an AST or any other structure represents a syntactic representation or a structured representation of some raw pile of text. Raw piles of text are pretty dense. So if people go to an AST, you're going to get an AST node. It's got a parent, it's got some leaves, it's variable count of leaves. You have some variable length arrays, and length text has a bunch of semantic information. Oh, I found constants here and constants there. Da 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 da. Suddenly, your AST nodes are average of 40 bytes, 60 bytes, something like that. Maybe 100. Depends on you can easily get them a lot bigger, but the average is still pretty high, and you get one of them for every interesting syntactic point in the program. Every lexeme roughly gives you a node in the AST, and suddenly you get a 10 to 1, 100 to 1 blow up. Yeah, that happens. Okay, I'm going to get the same rough order magnitude blow up, plus or minus some constant factors. I'm hoping minus constant factors, knock on plastic. That says it's linear time inflation, linear space inflation. There's no quadratic growth out of what I'm getting here, right? And all the parsing technology I'm using is all recursive descent. Hand-rolled recursive descent parser. It's going to blow 1-to-1 interesting code point to some IR nodes.
Yeah, sure. It sounds very interesting way to do it, and I really wanted to understand how this works. I've been trying to read your papers, like
yeah, I haven't written any in a while.
Going back to the ones where you actually describe it step by step, like how you came from. How you arrived at this
IR 95 paper from
yeah,
that's a good one. I like that one. That's the core. You follow what happens there. The rest of it kind of just follows on. The rest of it's like experience and practice putting it in use. But why did I get to there? How did I get to there? That's IR 95 paper. It's short and it's sweet. Here, we should find a link for that guy. I have one on my desktop. Let me see if I can get a Google-ated one here. Intermediate. So Oracle tech thing. Here's the workstation paper. It's still out there. Let me see if it has a link. I
think there's still a Rice. I think there's still a Rice EDU link somewhere.
Oh, there may be one. Okay, let me go find one on my desk unless someone beats me to it. We don't have Matt here to go hunt him down fast. Let me go. People talk other things or whatever. I'm going to go hunt this sucker down.
So when you say AST node clip, are you still talking in terms of the 1973 approach of a C struct that's just a passive bunch of fields that you stuff something into from the parser? Or are you talking actually?
What are you talking about? What's semantically different from what you're talking about?
Well, I've never actually built it in that way. I've always built them as active objects. So
what's an active object versus a C struct that you just make function calls against?
Well, an active object can reorganize itself within the graph or within the directed
graph. Of course they reorganize themselves. One of the function calls you do just takes the graph shape it's in and rewrites it, or the AST shape and rewrites it. That's a very common, obvious thing to go do. All right, it's one of these two.
Right. But there's a difference between saying, reorganize and saying, go find something and make whatever changes you have to make that work.
Oh, here I downloaded my own paper from ResearchGate. Let me get a Dropbox link and throw it in the throw it in the thing here.
Yeah, I think I managed to find your papers, including, I think, one. So this one, I think the one you're talking about is the simple graph-based intermediate representation.
No, but that's
right?
not the journey one. Yeah, that's the journey one. You want the journey one? I threw it in the journey one.
Then I've got this one called.
There's a simple yes. Read the journey one as a short, simple. This is going from old school to
from
new
quads
school.
to graphs.
Yeah. Yeah.
And intermediate representations journey.
Yeah,
right?
yeah. This is me
Got
one
that.
step at a time, translating from a classic LVM style IR to the sea of nodes.
Yeah.
Plus, it has some other stuff to do with, transformation steps and the like.
And this approach you've implemented in your new language as well, right?
Yeah, 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 yeah.
And if I wanted to understand the code, right?
Yeah.
What's the best place to start?
Well, the new guy doesn't have any execution yet, so it's however far you want to go. It's just I'm just doing typing now, and it's all a higgledy-piggledy mess. I would read those collection of papers on SSA form and what the IR representation looks like. What the new guy looks like is roughly the same. It has the usual accumulation of CRUD, like there's train wrecks of typing. You missed out on my year of not getting the typing how I wanted it. And so I have train wrecks of broken typing everywhere that I'm slowly deleting. I think I have the typing nailed now. So I'm busy finally doing actual implementation things. It's restructuring lots of things right now. Fine. Big mess. Half the tests, 90% of the tests don't run because they stop at the first step that says, and do something with typing, and then blow up because that's not ready. So if you want to understand what's going on, the easiest way is to talk to me. I can pull out code samples, but I can actually here. Let me, here we go. I'm doing this kind of graph diagram still, right? So it's still graph. It's still me trying to lay out the semantics I want and the IR I want, but it's all graph shaped things. It's more aggressive in some places than the Java one. It's missing a lot of optimizations because I'm not doing optimizations yet, but I have more semantic information kept around than I did at the Java level. And that turns in some places where the graph shape's a little different. And otherwise, it's largely similar to what the C2 IR is, sort of in a high level. The details are all different, but the high level has the same kind of notion. Nodes and edges, there's an edge for standard value flow. There's edges for memory flow, edges for control flow. There's new in this function headers. In the C2 version, there was only ever one function header, and it was the start of the compilation unit. And then everything else was inlines, but there were no other internal functions. Here I represent internal functions directly, and I can semantically and analyze through nested function calls and functions as closures and recursive functions and all that kind of shit all at the same time.
So in this language, if your functions have, it's all typed, right? So it's like statically typed. So you know the types of everything up front.
Yeah, well,
it's just that you use type inference to
you don't have to
help the user
type.
to not have to type it in.
Yeah. But it has to all strongly type before I'll begin doing code generation.
And you have closures, right?
Yep.
And is it like in Lua, what happens? You have closures, but these closures can amend stuff on the stack.
Yep.
Can you do that in your closures here?
Yeah.
So even after the closure has, even after the stack is unwound, how do you keep hold of the?
Well, so there's how you do it, and then there's semantics, meaning there's how you do it sort of at all, and then there's how you do it efficiently. So the semantic meaning is it's strongly typed as a stack frame that has types for the local variables that have side effects can come around. How you do it at all is you move it off the stack into the heap, which is what Lua was doing, right? How you do it efficiently is you move back from the heap back to the stack when you don't play that game. So as long as you don't do upwards exposed function pointers that you've escaped and with side effects, you don't have to have a heap versions. So as soon as you do that kind of game, you get a cost model that's different. So I'm in a zone of also where I want to track cost models reasonably well and give people sort of guarantees. And one of them is you can say, no upwards exposed here, that'll be your default. And so, cost is cheap. But if I make a function and that's got a local variable, and then I return the function pointer, the local variable is now stack frame that's been, returned, can be updated and whatever, it goes to the heap, you got an allocation. And so your cost model is different than, the model that says, I just called a stack and then I unwound the stack. So there's a cost model game definitely going on there. Aaron just showed up. So we're actually growing up to like a reasonable crowd here. I kind of thought day before Christmas, I was going to get 2 or 3. Excellent. So I'm sorry. So did that answer your question then?
Yeah. So I guess, so then it has to be boxed, right? So whatever references you have to hold on to, you have to move them to the heap.
Yes. And you said boxing, I call it allocation, but yeah, it's boxing, whatever you want to do with it. Yeah. Okay. Now, in the actual implementation of the parser and the IR right now, all stack frames are treated like a struct, a typed C struct, C class-like thing, every one of them, and they have a backwards pointer, hidden extra variable for a backwards pointer. That's the small step operational model that I got going on. And then there's, easy optimizations that flow from that says, hey, no one's doing anything weird here. I'm just going to do stack frame it and be done. And, all the kind of usual things. Hide the backwards pointer as just offsets into the stack. And there's a lot of easy optimizations going on. The other one going on here is that structures that have final fields that are constant values that are set at the beginning are moved off into basically a class object. And then only the variant part is actually allocated locally. So ints have fields that are all the functions that take an int as the first argument. So all my operators, .eq, .hash, all the things you want to do with an int that aren't int-like, that might need boxing elsewhere. I've just declared an int as a struct. It has a bunch of final fields which have pointers to functions. Well, pointers to functions are all constants. So they all move off into the class object. They're not in the int struct. So the int struct has only itself as an int. And I have a strongly typed int that knows that if you do a load of a final field, I'll go to the class object for int and pull it instead. And semantically, it's as if the int has a bunch of fields that represent all the functions you can call and any other global constants you want to throw in. If you're not an int, you might have other global constants that just come out of the class object instead. So semantically, I'm ready to pass an int as the key to a hash table. And the hash table, first thing it does is says, take this thing called .hash. Well, int knows how to call .hash. But in order to make that not require boxing, I will have to specialize. I'll have to know that this call to hash is taking int, and that call to hash is taking a string. And I need 2 copies of code in order to avoid boxing the int.
You can always use C++ templates.
Yeah, well, that's what it is. It's not, but that's the semantic concept. You're going to clone the code in order to avoid boxing the int, in order to just pull the hash out of it by code that doesn't understand how to load a hash out of an int.
You specialize it so you don't need a pointer to the V table as part of the value.
That's correct. I'm specializing it so I don't need a pointer to the V table. Yep. And then that'll be a hard guarantee that you can request on anything, and ints will have it requested already as a default, but other people would make that request. So if you screw up and say I have a large complicated structure, I'm expecting it to not be, I'm making a complex object, as in the scientific term complex. It's got a real and an imaginary part, right? But I want it to have no V table. I want it to be a value object. Then you can ask for that. And if you accidentally put in something that requires boxing, you'll get a compile time error. It'll be, it'll be a semantic analysis error. Hey, here you're using a complex object in a way that requires me to box it. And you told me not to box it, so I'm going to complain at you instead. And obvious uses for this are all the places you would inline small complicated objects like pixels, which have 3 bytes of RGB. But I want to say, and then now dither this thing, and now, cap the color, cap it, or there's 100 things you do with color pixels.
And I can imagine an implementation that would figure that out automatically for you.
I don't know. I can't think of all the things I would do to color pixels or some pretty clever shit there.
No, I'm just joking that it's a perfect opportunity for dynamic optimization, statistically driven.
Yes, absolutely.
Which is your trick. So
yes. You were, by the way, kind of fuzzy glowy there. It's like a different camera.
No, same camera. It's just I'm in heaven now.
Oh, good. Glad to hear it. Good for you. As long as we keep getting, conversations from heaven, it's all good.
Yeah, I've got some wings to hand out tonight. This broker is in trouble.
Sounds like fun.
So does that structure give you a type dynamic kind of for free?
What's a type dynamic?
So if you have pointers off to the structs that define all of your classes, if I want to make a thing that's like, I have a list of pointers to something and everything's a fat pointer and it's got one pointer to the type and one pointer to the object.
So what I just said here, what Cameron just said is no vtable in these things. So the compiler, the typing system has analyzed and proven that there is no vtable needed before the program is declared type safe. Or else you have declared that you're okay with boxing the sucker.
Right. And yeah, Aaron's point is that there's a third option as well, which is you're not boxing, you're not hard coding the pointer, but you're actually passing the vtable pointer as part of the ABI.
Right.
Instead of, yeah.
I should allow that.
And if I put an object into a list of type dynamic, then I know I'm boxing it. Like I put it into a generic list.
Right. Well, that's the case where the compiler wants to tell you that he has to box, so you have to give permission to box.
But in theory, all of your pointers could be fat pointers. So I mean, it's one more potential implementation.
No, if I'm fat, that means it has a vtable, but the other bits are just being passed by value.
Yeah, but there's no reason they couldn't be passed in a fat pointer.
Well,
because you just pass the second half of the pointer to the method in the first half. It's just like you do with C++. You just pass the this. In the case of an int, the this is the int itself.
Yes, and in fact, that's how I'm doing that right now.
Right, but you're not passing the vtable as part of the ABI payload. In other words, you're not pushing the vtable into a register when you call a function.
The semantic, that's correct. Well, right, and I think I could go there. So the semantic analysis right now says I don't need the vtable, so it's not getting passed. The type dynamic version says I do need the vtable, but I don't need to have a memory location that has allocation and a lifetime management and a free and an identity that allows separate side effects. So those are the WOD that says I took a thing that the user knows has a memory footprint, has an identity. Like 3 is a 3 is a 3 is a 3. 3s you can't tell apart. They're value objects. But a box 3
they have an identity of 3.
Yeah, and a box 3 and a box 3 have two different identities, and they will be unequal. Equals pointer equals will claim them different. Where dot equals will say they're the same, but pointer equals will say they're different. This is the land of Java. No, I know you have your version on this, and the reason for that is because I want to make it clear that I'm going to say the user is responsible for choosing boxed, and that means he chose to have an identity that was separate from value equivalents. Or it's not boxed, but maybe I need to have a vtable is the third option that Aaron's talking about that I've come and gone on, and I don't have a current immediately readily available solution, but I'm not disallowing it either. So I certainly should be able to reach a point where I can allow the third option there of saying, yeah, here comes the vtable, and here comes the contents of the fields, the 3 bytes representing RGB, and then I'll go do something with those as a key to a hash table, which takes the vtable and finds the hash, but there was no memory identity involved. The point object never got allocated in main memory. It was all passed in registers. I think that's what I heard is the third option. No vtable at all, vtable, but you still don't have any memory location. Everything got jammed in memory and you have an identity. There's another one that's a performance game, which says, oh, I had a big fat hairy object that's a value object. I stored it in memory because it's too big for all my registers. But now I'm totally responsible for the lifetime, and I'm not going to tell you I put it in memory. And so you can't see the identity. And maybe I do shit like copy on write optimization, shit like that. But that's all optimization pieces. That's how you handle somebody says, oh, I want to make a value object that has to have 500 bytes of shit in it, right? I want to pass 500 bytes around. I'm going to eat all my registers up and all my stack space over and over and over again. And I'd rather do copy on write or whatever. Swift is doing this game, right? This is a Swift game.
So a box containing a complex number is a different type than a complex number.
Yeah, yeah. One has identity and one does not. Capital I integer is different from, in Java, capital I integer is different from lowercase int. Those are two different types. One you can lock. You can call wait and join on, when you cannot. But locking's like on every object.
What's your goal with the language? Like, what's it meant to solve in terms of?
It's meant to keep me busy. It's my gardening.
So is it just like something fun you're doing rather than trying to solve a use case?
I put down a higher level concept for it, and that's because back in the day when doing Java as a large C++, JVM as a large C++ program, there's all these cool things you could do with purely functional languages and strongly typed languages that you couldn't cheat on that I never got any support for out of C compilers. C, C++. Oh, back then they didn't know atomics out of C either. Volatile was a total lie, didn't do shit. We had all kind of issues that were stupidly solvable if we had written the JVM in Java, but we needed the low-level support as well. So can I do something to help somebody who's writing device drivers? I've written device drivers before. Can I write some device drivers using some sort of high-level, strongly typed structural thing? I would love to do that if I can boil it also down to the low end. So I'm trying to bridge a broader semantic gap from high to low and give support for people doing systems level programming while, not throwing away all the goodness and light of the last 40 years of type analysis and functional programming experience.
But it's a huge subject, right? In the sense that, like, so you could go down the route of trying to do everything, say, for example, Rust is doing or C++ is doing.
That's totally Rust-like analysis of memory is on my to-do table. Yeah, on my roadmap. And I've certainly done garbage collection in a big way. And so that's on the roadmap too. And there are times we went one, there are times we went the other. So, yes. Like, if I'm not going to do it, who is? I'm done waiting. It hadn't happened yet. So I'm doing it. Can't wait much longer. I'll be dead. Hopefully I got another 30 odd years.
So, and of course, we all benefit from what you're doing. So that's great. It's just that it's very, very, the reason I'm doing it, because it's just a fun project. I know it's never going to succeed in the sense that
you absolutely
it's impossible for a new language to succeed almost, right? Unless you have big corporations backing them.
Right. Absolutely got to have fun. Now, C did not have a big corporation really backing it. AT&T looked the other way while Carnegie and Ritchie ran to town with the thing. They were like, well, we want Multics, Unix. C, what the hell? That's for Unix. Fine. Ada's for Multics. That's the answer.
I guess they got lucky, but it's very difficult, right?
The right language at the right time. I'm not claiming anything else about what I'm doing here. I'm not, I would love to have that happen, but if it doesn't happen, it doesn't happen. But that's not the goal. Some of the goal is see I could do it. Some of the goal is solve some hard problems that I've not seen solved before. Some of the goal is have fun, use my skill set in the best way I can. So. And then one of the things I think I've accomplished now, and knock on plastic, no hard proofs. I think I have forward flow typing like we were telling you to go do with LuaJet, integrated with Hindley-Milner style typing, which does, polymorphic type variables. So I think I have a better typing answer than ever before, and I'm hoping to have it come out.
And is that something one could reuse? Like, for example, if I wanted to reuse your Hindley-Miller system,
Yeah, it's
could I reuse
an algorithm. However you reuse algorithms. I can't even patent an algorithm. That one's. I claim that you need to be.
Let's talk about Google versus Oracle.
I claim you have to be somewhat of an expert in Hindley-Milner and somewhat familiar with forward flow typing to understand the algorithm and how it works. And I don't currently have it boiled down in a way that you would want to apply it to like random piles of Lua. Like I have a tiny core AA language. Core AA is really typed lambda calculus. It's basically all you get out of lambda calculus that I'm running this combined algorithm on. I don't do great error messages. I don't do a lot of fancy, there's certainly no fancy parsing going on there. The parser is like 50 lines of code. Is that a language you want to boil your stuff down to so you can get type analysis and then reverse that? Probably not. So then you want to move the algorithm into your own thing. And now that's a piece of work where you have to understand the algorithm, for which, like I said, you probably want to be somewhat comfortable with Hindley-Milner already, somewhat comfortable with forward flow typing, probably somewhat comfortable with what a monotone analysis framework is. If you've never heard one, then maybe you got some reading to do. What else to say there? I would love to have more feedback on that. I was kind of waiting until I got the language in better shape to go back to my theoretician crowd and say, hey, look, take a look at this. I went to a theoretician crowd for 6 months. I got some good stuff out of it. So, and in particular, I got some really obnoxious test cases that kind of pointed out the core essence of what I was trying to do. So I think I'm alive. Like I said, I think I'm alive and well. Pass all my tests in all possible modes, and I think they're covering all my corner cases. So now I'm ready to go implement, which is what I'm busy doing. And if you want to talk Hindley-Milner and forward flow typing and their combination, I'm happy to do it. But that's a high theory discussion. And like I said, I'm happy to do it. And I don't have any prepared, easy to read, easy to go visual aids or anything either. It's just like me rambling.
Hello.
No one's jumping up and down for that one. It's all good.
Hello.
Yeah.
Yesterday I was reading a Kotlin roadmap and I came across this feature request, which was titled adding statically accessible members to an existing Java class via extension. So at the moment, we can have a static extension functions in Kotlin as long as we have defined companion objects inside Kotlin class. But it's not possible to have a companion object in a pre-existing Java class. So how can we have statically accessible members for pre-existing Java class?
You got some links so we can go do some reading? Yes. And to be fair, I had trouble with your accent and you came in without much announcement. So I wasn't focusing on what you were talking, and I would love to hear that again. Slower with the link here. Kotlin, statically accessible members. Yeah, Kotlin. Yeah, well, you have some sort of Java execution of Kotlin already. So somebody's converting Kotlin to Java already. Yeah.
Smith, are you working on Kotlin or are you using Kotlin?
No, I'm just a university student. I completed my bachelor's and now I'm applying for master's. I've applied to some Canadian universities. I'm from India. So
Good
sorry
luck.
for the accent. Yeah.
No, it's fine. It's me. I have very difficult time audio processing. I'm really bad with Asian accents. Indian accent's only slightly bad, and I just have to pay attention. And it helps me have a video because I actually lip read, and that helps. I don't lip read really like a deaf person does, but I definitely helps to see faces. If I haven't heard your voice, these guys I've all heard 1,000 times before. Well, Debian do, but everyone else here I've read 1,000 times before, and so I'm all good with them. New person, new voice, takes me a little bit to get there. Nothing to do with your accent.
I do wonder if someone was looking to do a PhD in languages or compilers now, what university I would send them to.
Oh, gosh, I don't know. You know, around here in California, Stanford and Berkeley both have very strong comp sci programs, but I don't know specifically they do compilers. Berkeley's done hardware and compiler hardware support for a long time. I don't know where Stanford is. And University of Santa Clara, which my son's going to, has apparently got a world rank for computers and game design.
So there's a couple in Europe. In fact, one of the guys on the call is often, not today, but
no, he hasn't been in a while, but he's one of the universities there.
Footmark. Footark, yeah.
It's doing array bounds analysis for multidimensional arrays so that you can do array multiplies. And
so he's a professor in Copenhagen or something, I think.
Yeah. And actually for theory in computer science, there's a lot of strong European universities.
Yeah. So Aarhus University is big in language stuff. In fact, one of the architects from VA is a professor there.
There is one in Switzerland. I can't pronounce it. Switzerland, in Lausanne.
Lausanne. That's it. I was going to say Lisa. It's not Lausanne. Not Lausanne. Yeah.
Switzerland.
Yes, I didn't go to Switzerland because the airline screwed up my flight to go do a PhD. I was the outside professor for a PhD student doing a PhD review, and instead we did it online.
Carnegie Mellon has a pretty strong PL.
Oh, right. I'm on their fucking mailing list. Yeah, right. Well, I asked for it. It's fine. Interesting stuff floats by.
You can always go to Oswego in New York and chat with Doug Lee.
I would love to hear Smith talk again about we started to do something with static members to Kotlin and versus Java, and I didn't get all that.
Right. So there's a static extension functions in Kotlin, right?
No, I've never coded Kotlin in my life.
Okay. So basically in Kotlin, we define this companion object, and we can extend on that companion object and can access static functions. Like Kotlin has no static functions. Companion object is just a nested static class which compiles down. And the feature request was, how can we add statically accessible members to an existing Java class via extensions? So the pre-existing Java class, it's a little bit difficult for me to explain this. I've shared the link.
It came out of a jar file. You got a .class file defining a Java class. Yeah. And you want to use an extension to go add some static members.
Right. But to have extension function, we have to add a companion object, which is not possible. So how can we add static?
So break apart have to have a companion object from I want to have a static function I'm going to call that's in the class namespace for this class that's in a jar file.
Right.
Okay.
And you basically have two options there. One is the JVM has hooks that allow you to rewrite classes as they load.
Yeah.
So that's the way we used to do this.
I've done
Right.
I've done that.
And then the alternative is within the same class loader, you simply inject a separate companion class and use name mangling to identify it.
I've done that. That was how H2O does its communication. When I load a class that's going to get communicated over the wire, I build a serialized, deserialized class as a separate companion class, and I name mangle to find it. Yeah.
Oh, so that way we can have extension function on that class. Okay.
Yeah.
Because you can actually rewrite pretty much every Java class as it loads. So even string and whatnot are fairly safe to do if you know what you're doing.
Yeah.
But it's probably better if you're running in a system that may have other users, not to rewrite the system classes themselves.
Yeah, I was gonna say, don't add fields to string unless you're trying to confuse someone.
Yeah, you cause some hurt there. Yeah.
Well, and it's like if you're on an app server, it may have other things running that are, you want your stuff to be composable. Which means,
Presumably, if you're on an app server, the app server has already come up and string is loaded and it's too late. And then he loads you, but you're in a different
Right.
security domain, so you don't get to hack the app server.
but the hook for rewriting is actually done before main, so to speak. It's a command line hook.
If you do the extensions that way, yeah, it is. But then you demand that the guy launching your Java app take your command line, which, like,
Right.
if you're an app server, you're like, no. But if you're just like, I'm doing my own app, yeah, you do that. H2O first. Sorry, go ahead.
I was going to say, Smith, the nice thing about static extensions is that it doesn't really matter where they are for the most part, other than some security questions. So as long as the compiler is aware of the rules that you have, that is, if you have a preset rules for whether it's name mangling or locating or whatever.
Yeah.
As long as everyone plays by the same rules, there's no reason that it has to be. Say you want to add something to string. I don't know. Does Java string have a reverse function? Let's pretend it doesn't. I can't remember. But if it doesn't, you want to add a reverse to string, it doesn't have to be on string. Right. So as long as the compiler
to access all the members and so, but string, it has a okay, fine. Yeah, right, fine.
Right. So as long as the compiler knows that when you call string reverse, it goes, it knows to look up and
different
mangle.
location. Yeah, right.
Right.
Exactly. Yeah.
And for those, it has to merge between the things that are on string itself and the things that you've added to it. So it's more complicated, but still.
Well, you have to know everywhere you had a string that you would call a string function on, that he would then do the name lookup on reverse and inject code that says, I'm going to do the other way around. That one's a little more complicated. I did it by injecting new methods inside of the class that was loading that called off to the companion class to do all the hard, heavy lifting. And the new methods all had cheaty illegal names that you couldn't write.
Yep.
But there were valid names from the Java spec or for the JVM bytecode spec, and that I could then call them and they would just forward off to the guy who did all the heavy lifting, come back.
Yeah, and the other thing is, not that this matters in this case, since you're doing static extensions, but for non-static extensions, it's a little more complicated. But Java has 4 different invoke ops, and one of them is actually extremely useful because it allows you to kind of laser target your invocation. It's called invoke non-virtual, if I remember.
Dynamic.
Invoke dynamic.
No. Actually, there's 5 now. There's invoke dynamic.
Oh, okay. Yeah, there's invoke non-virtual. Yeah, you're right.
Because there's invoke static, invoke virtual,
non-virtual. Yeah.
Invoke non-virtual,
interface.
and invoke. That's right. So
Interface.
non-virtual is the one that allows you to call super, and unlike any other language in existence, or unlike any language that was designed in Java, from a certain level of inheritance, say you're on foo, you can call super bar. So you can hop columns in the V table. Well, depends which way you're shaping the table, but you can go from foo to super bar.
Yeah.
On a single, so you can skip the virtual call to bar on your level or above if there is, and kind of poke down. So it's a pretty handy feature for doing this kind of work, but you won't need it for static extensions.
Right.
I guess my question is, what is the win for doing all of this hackery over just creating a class that you call string tools and put all of your things that manipulate strings in that and hope the optimizer cleans the things out?
Avoid locations.
He's got an old class and he wants to do some sort of, injection on it, agent injection.
Right. Like a Java string class, let's say Java string class lacks many useful functions. And as of Java and Kotlin interoperability, after having these features, we can add some useful functions to string class without adding it to actual string class. Yeah.
about something like cake into extension methods, but without allocating a wrapper class on each invocation. Is that correct?
Yeah, right.
So I just tried this in Scala 3, and you can't do it in Scala 3 either. But what you need for extension methods in both these languages, Kotlin and Scala 3, is a type. You have to add it to a type. So like I can add to the string type, which what you want is the singleton object. And Scala 3 has singleton types, but Kotlin doesn't, I don't think. But I just tried it, and it doesn't let me do it on the Java class. It lets me do it on a, like I can add a method with an extension method to, let's say I make an object in Scala, I can add an extension method to it using the singleton type. Just like the type I name is singleton type instead of the, trait or class.
Right, the same thing.
However,
Yeah,
what you could do if you can control it, if it's your own class, you could have it extend an interface. Have the, oh no, you can't do that. Never mind, there's no way to do it in Kotlin, I think. Except by code manipulation, but I don't know about that.
So one of the things that comes up here for adding a method like that is, let's go back to the reverse case. You're looking at old code. It has no calls to reverse in it because there wasn't a reverse that you added. You're adding a call reverse off a string, but you're the only one who has a reverse call. No one else does because there ain't no reverse. So instead of calling some string dot reverse, do some static global reverse of a string.
Yeah. It's just, I think extension methods are syntax sugar.
Yeah.
Well, they turn into that.
Yeah.
So it's just syntax sugar.
It's just syntax sugar. And in particular, you're writing both sides of it. So just pay the sugar cost. Yeah.
But anyway, I didn't know that Scala 3 wouldn't let you do it on Java. And I don't know why they don't. That's kind of interesting. Like I tried it on Java lang integer, see if I could add a method to Java lang integer dot type, a static method, and it didn't work.
Java lang integer?
Yeah.
You can't add, yeah, you have the jar file issue.
No, I mean, it's not really adding it. It makes, what it does is, like when you make an extension method, it just means you don't have to pass in the object Fred.
Yeah.
You just Fred dot method,
Okay.
And that's all it is, the syntax sugar. But you can do it on any type, except you can't do it on Java singleton types, which they do exist in Scala. You can say a singleton object for Java lang integer. You can say that there is such a thing. That's how it looks from the Java perspective.
Okay.
All the static methods show up as instance methods on the companion object, and there's a type for that object. It's just that one object.
Okay. All right. Sure.
But it doesn't let you use it in an extension clause for whatever reason. Probably because it's just too much sugar, I would guess.
Yep. Well, let us know how it goes there, Schmidt. It sounds like you got some work to do.
Okay.
I suppose the AA answer to that is just use dynamic dispatch.
Well, I don't have any code, so I don't have any implementation, so there's no old code to be extended. So I'll just add the reverse up front and problem solved. You asked the question, how do you extend old code with a new guy? And I don't know that I'm going to be able to accept the typing where you add to a previously typed system, you add a new method that wasn't in the types before.
But you do have polymorphic dispatch, right?
So if you land in the zone of a polymorphic dispatch, then you're a string or a string plus a extra reverse keyword or whatever, reverse function or whatever, that'll still work. I'm arguing a different thing. The polymorphic types will just do that one. I'm arguing that if you take a thing that I have proven is type safe and correct, and you want to modify something inside of there, I have to rerun the type analysis from scratch, basically. And I cannot verify or validate or tell you upfront that certain kinds of incremental changes are guaranteed to retype correctly. I do not know that as a fact. So it's possible that some incremental changes.
Be known.
Well, maybe, you know, with some incremental changes may be knowable as this will always work. It's fine. You know, I want to add a method that no one's ever called before. That seems like it ought to work, but I don't know, but it seems like it ought to. There are other changes that you might make to a type system that I'm pretty certain that we all agree we wouldn't know if we run the type analysis, but I don't know where that line is. Where
generally the ugly ones are where you're introducing an ambiguity that's neither in the target nor in your addition, but rather introduce ambiguity for someone else who's already been evaluated without ambiguity.
Yes.
So
yeah.
Yep.
Yeah. Somebody adds a reverse method. Somebody else has got a reverse method. I eat your jar file. Suddenly your jar plus my jar like complain at each other because I got two reverses that I don't understand which one or something. There's some amount of that. When I want to do incremental compilation, I'm going to, you know, have to declare ambiguity across things, and I will do an incremental but a full type analysis. When you merge modules or cross module boundaries, I'll have to do that. So yeah, I don't know. Like if you subclass, like I suppose I let you subclass string with a new version of string that has a reverse call. And maybe that one just works. That one sounds like a reasonable, I could do this. That's polymorphic type variables for the win. Are we looking at your dog keeping you company here? What's he know about type analysis? I got rid of all my mammals. I've been in mammals in my house for 20 odd years. The kids are all gone. The extra mammals are all gone. We were all ready to start taking all our vacations without dealing with having cats and dogs and, you know, pet hotels for whatever. And then COVID hit. It's like, oh, come on.
Next topic.
Okay, so I have a question.
Yeah.
So, okay, so we were talking about device drivers earlier, at least I remember it got mentioned. So my question is, how do you handle interrupts in a programming language? Like, as far as I know, there's one example, which is C, and it has this thing called signal handlers.
Yeah.
And so you get a signal, it executes the signal handler, and you can only do signal handling safe things, and that's
as far the DVM's full of that shit. And there's so many signals we catch and handle.
As far as I know, that's the one way to handle interrupts. So I'm wondering if there's like a better way that doesn't require.
I would certainly want, one of my goals in AA is to enable this. It's like an asynchronous function call, right? Except the expectation is it's coming in on the same stack as whatever you're calling already, and are you reinstrument capable, shit like that. One of the more miraculous things that happened just as I left from Sun is some clever soul decided that when something crashed and burned, they were going to crawl the stack and print out things that were going on, kind of sound, you know, as part of the dump, except they had to handle all the in-process signal handlers, which they screwed up. So the first time I took an update from Sun to go, you know, into Zool to go deal with whatever, when I figured that one out, it literally took me a month to fix all their bugs in how they would handle exceptions and nested exceptions, because the debug printer would trigger exception failures because it was confused about, I mean, even on x86, it was, I don't know what the hell, where it worked for them. It did not work on my x86 version, certainly didn't work on the Azul version, because the signal handler was trying to print the signal handler, was trying to print the signal handler. And it's like, oh, come on, guys. Stop. It was pretty ugly. There are roughly 20 variant, somewhere between 10 and 20 variant handlers I had to deal with to pretty print the stack on a fail. You could be in a TLB handler when you got your first fail. And of course, inside of a TLB handler, you can't do shit without triggering another TLB, which you can't do, right? And so it's just uglier than sin to get unwound from that kind of stuff, including pre-allocated printing buffers so that you didn't have to ever allocate. You couldn't do a malloc. You had all this couple of Ks set aside for a stack frame dump that you could manually walk through by bumping a pointer and a global variable, and no one else could touch it except the dump guy in the middle of dying. Whatever. So yeah, I think the JavaScript lands for browsers kind of started down the path, right? You get asynchronous callbacks. Now make your language safe for asynchronous callbacks. The whole signal handler guy, that's just a way to set up the asynchronous callback. That's not the issue.
Interrupt handlers have always been a real pain. I've never done it in C, but in assembly, what you would do is you would generally you'd basically black out. So x86 had a CLI op that would clear your interrupts, except for your NMIs, your non-maskables, and then you'd basically grab as much data as you could, and if you could, you'd set it aside and then return and let it be handled by someone else, because you didn't want to, because anything you did during the CLI block because anything you do there, the computer would be just completely locked up until you put the interrupts back on.
Right. So basically, there's an event loop thinking you have to go through, where the event loop says, I'm going to handle interrupt events when they come up as my best effort at what I would call a safe point. And during the interrupt itself, I can't take another interrupt, or else I have to have recursively re-entrant interrupt handlers. So and in fact, these things happen, by the way. So what I do, what Cameron didn't mention here, is the first step in is you test the bit that says recursively in an interrupt. And if you got out with whatever, I lost some data I couldn't handle. I'm in a UART handler doing signal processing for a serial line. The serial line buffer has so much, and the guy's supposed to drain it into the OS buffers. If the OS didn't get around to draining it, your hardware device handler just throw bits on the floor. He's got no place to put the bits.
Right.
So you tested that you're overrun, and you set the overrun bit and you got out. If you're not, you set the bit saying I'm in the handler, and now I record the bits into my ring buffer, and I set the in, and I do the fencing so the OS gets the right thing, and I got out. And the OS's job is to recognize, and when I set the bit in the OS saying, dude, and now the OS at his next convenience says, I'm going to halt the user processes, I'm going to push their stacks, whatever, I'm going to do a kernel switch, I'm going to eat the UART device drivers buffer into an IO buffer for the appropriate task at hand and clear the whatever. And those all had to be sort of reentrantly enableable, workable. And some of the early versions of things, you didn't have a CAS, so you had to do a Decker's algorithm to lock in the interrupt handler against the OS who was in his version of things, moving it from the interrupt handler, whatever. So there's a serialization game, there's a asynchronous callback game. There's definitely things you could do better now. These days, I would think about doing better.
Well, back then there was no real OS, so all the device drivers were written by different people, and none of them played by the same rules. So the real reason you couldn't do anything inside the driver itself was because you didn't know what rules everyone else was playing with.
Yeah.
And so, you couldn't. So basically what you're trying to do is just capture enough information that you could pick it up from, hopefully from userland lately, or if not from userland, from a timer callback or something like that.
Something would come through at a reasonable time that, right, but you had to get in, get out, and you couldn't dick around. Like in particular, you couldn't malloc. And there were definitely times where we accidentally called malloc in callbacks, and you'd be in the middle of a malloc call, take an interrupt, and want a malloc again inside of the malloc call. And of course, that was death. The JVM hit this kind of bug all the time. That was one of our many evil things.
But if you remember the old floppies, every time you would use a floppy, like the machine would lock up, and not even the mouse would move.
Yeah, I remember that.
So
that was
that's how to not write a device driver.
Yeah,
because it has the highest priority, same as the network.
Well, it's not a priority question. It's that it would turn off all the other interrupts, and the mouse was an interrupt. So the mouse movement was actually in Windows, for example, drawing the mouse moving is actually done by the device driver at the device driver level, not by the OS.
Yeah.
So when you're using the floppy, it's turned off. What at the time was PS2 interrupt. Nothing works.
I remember that. And I know why it was done that way. I mean, I did that sometimes too. That was part of it.
I remember the strange noises that the floppy makes.
Yeah, yeah.
Are
Well-
you talking the Apple? You're talking the Apple floppy specifically?
The Apple IIe.
Yeah, yeah.
Because the Apple II floppy made those noises because they asked the drive manufacturer to give them the floppy drive without the controller.
Yes.
And so they actually used the CPU to do the controller. So
Yeah.
basically they slammed the head instead of asking the controller to move the head, they just slammed it all the way until no matter where it started, it was at the end. That's those noises.
Yeah.
There's a great, I think I may have shared that link with you at some point. The Steve Jobs, no, not Steve, Bill.
Bill Joy? No, you know, Wozniak.
Wozniak's, because basically they didn't want them to buy these drives without the controller, so they sent them 10 broken drives, and he got 7 of them to work. So they actually gave him some sort of award or something. Let me see if I can find that. That's a good Christmas link. Wozniak.
Excellent. But yeah, the issue is in the interrupt handler, you have to think about you are running on somebody else's stack frame. And what are they doing when you're running? And because it's an interrupt, it happens on any clock cycle. So they're mid-function call on an x86, they've pushed the call, but not the return. They haven't pushed the frame entries, there's no stack frame. So, you know, whatever things, they're at the edge of out of memory, out of stack space. So the interrupt driver pushes them over the out of stack space. So the interrupt driver itself takes a stack overflow. I don't know, bajillion of these things. Over the years, x86 has gotten a little better about it. They do, you know, more flipping to different modes and out of user land and the like. So if you're not in user land, when you take the interrupt handler, the OS is guaranteed got stack and shit like that, and life's better. But you still have the same issues for the kernel itself, except the kernel people write in this funny style so that they can, you know, have it work. And now, if you want to do interrupts that way, you have to play those games or get language support. If you do interrupts these days, then it's just what you said, you take a callback. And the callback though does come from your point of view at any clock cycle. So you're wherever you're at when you take your callback, including running inside, you know, malloc, mid garbage collection, whatever. One of the things I added to Zool was a guaranteed way to crawl your stack on an interrupt and a random timer interrupt. And so that required a lot of shenanigans to decipher if I was mid constructing a call stack or not.
And you guaranteed you didn't have a garbage collection happen while you were handling an interrupt, because that code was just written in C++ and not Java.
The interrupt handler was, the interrupt handler was written in C++. The user mode interrupt handler for crawling a stack would run on the same stack as a user JVM, normal Java thread. It could be taken in any clock cycle inside the JITted code, and it would now crawl your stack with a minimal amount of stack frame itself. So it wouldn't trigger stack overflow very often. You'd have to try hard to make it trigger stack overflow. But that was made safe as well. And then, but the stack could be any partially built thing, and certainly could be mid garbage collection. Mid garbage collection doesn't stop you from crawling your stack. This is to get a profile, as a sampling profiler, as opposed to a safe point profiler.
Because the save point profilers lie to you?
Yeah, safe point profilers lie to you, yeah. So one of the things I did at Azul was get a sampling profiler alive and well. The one at Sun almost worked, except that it periodically took samples where it couldn't decipher the stack and kept crashing, so they turned off. And that was because the stack had times when it was unclean. And if you asked the stack when it was unclean, you got garbage out of things, which turned into, the main one it turned into was you couldn't ask, the OS couldn't reliably tell one thread what another thread's stack pointer was. So that one turned into garbage collection once a year would crash Deutsche Bank. I burned the same bug 3 times at 2 weeks a pop to decipher the bug. The last time because it crashed Deutsche Bank. The first time was the real one caught during engineering. The second one was a late stage time to go ship this thing. Oh, what the hell happened here? Turned out to be the same bug I fixed once before. They said, no, change is too risky. We're going to ship anyhow. And then it happened the third time at Deutsche Bank, who said, we're not paying Sun another dime until your root cause this bug. Another 2 weeks of my life burned. So that sucked, but there it is. Yeah, and the end result was OSs in general will not tell you with perfect reliability, 99.99, but not 100% reliability, what a stack pointer is of another thread. So if a GC thread wants to do a crawl of another thread, you will get a lying stack pointer once in a bajillion times. It will pass all your easy tests for correctness. It won't be wildly crazy, but it'll be wrong still, and then you'll crash sometime later because you crawled the stack wrong. Once I fixed that problem by not asking the OS for this information, I could crawl all my stacks all the time. And that's because I demanded certain things about how the stack was done whenever I crossed JITted code boundaries. From JITted code to native code. Sorry, from either interpreted or JITted to native code and back. At that boundary point, I put a flag on the stack that I could do guaranteed memory ordered against a reader before I made the native call, and that would let me crawl the stacks reliably. And after that, I can crawl them reliably in interrupts for for profilers too. So the couple of morals there, one of them is, boy, them stack crawls and random interrupt points are really hard. And don't trust the OS to give you that answer unless somebody's really hardcore about it. I claim that even as of 10 years ago, I got reliable fails. And I asked people 10 and 5 years ago from the OS community, and they said, yeah, there's probably some holes in there and we can't guarantee. So I claim, don't bother. You want to know what I did? Everyone's quiet now. It's stupid. The only thing I did was I push the program counter of the method next method up on the stack before I let the call puts the return on the stack, and I force an ordering between them for another thread. And so if I find a return address to something I'm not clear about, I know right above me there'll be a program counter of how I'm supposed to crawl, and I must be in one of these funny transition frames, and away I go. If the return address is something sane, I can crawl. The return address is
that doesn't sound like it would consume too much memory. Is there a performance cost to that?
Yeah. Well, calls from a Java frame, from a hotspot frame to a foreign function interface go through a lot of overheads to support a bunch of things that are not necessary if you know for a fact that you have only trusted code that you're calling. I see that, Cameron, but it's not quite lunch yet. That doesn't look like lunch though. That looked like whipped cream and berries of some kind. Yeah, fine. So when you make a foreign function call in Java, all oops that you're passing are strongly typed. You know what the object pointers are. All object pointers you're passing get handleized, and only handles are passed off. And a handle is returned if a handle gets returned at all, and then you unbox the handle on the return. So that happens going in and out. Because you're boxing them, they're pushed on your stack, and there's stack annotations that says, here's GC, oops, you have to crawl. They're live strong pointers. You had to reorganize the call conventions because the typical Java convention knows there ain't no var arg, so it doesn't put floats in the int registers for var arg support, which C does. So he gets a better calling convention, but he has to shuffle when he goes native code. Fine, he gets this argument shuffle. He puts a profiling byte on the stack. That's a common thing for people to do tag level profiling. He puts this funny program counter value of the next frame up so that I can hard guarantee know that from this point in the stack down, the stack is locked. That was the other piece I did. I have to CAS. I have to CAS in the who owns the stack. Like a JITted code owns its own stack and mutates it furiously, or the garbage collection owns its own stack and mutates it furiously, and the JITted code does not. But native code won't own its own stack because the GC is not touching the native code stack. The GC totally begin whacking the stack, the Java farms above you. And this is the common case when you call blocking IO. You call the native code, makes a blocking IO call, you're blocked for a long time, garbage collection must run, it goes to your stack, it has to skip all the native frames. So there's that hook that says, and here is the first non-native frame. And from here up, I can crawl. And then when the native call unwinds, comes back, he has to take the lock to get his own stack back. If he fails the lock check, he has to block, waiting for the GC to get done mutating his pointers before he's allowed to run. So you have to release a lock going to native code. You have to take a lock coming out of native code. You have to cas in and out this extra word, which is the actual lock acquire and release. You had to handleize all oops, you had to shuffle the args. So on average, a typical native call takes 30 to 50 extra clocks over standard x86 call for all this shit. Also, if you're synchronized, you have to take a synchronized lock unrelated to the GC stack lock. So yeah, there's a bunch of extra overhead. Now, if I know that I'm calling code that does not block for a long time, I don't need to block for GC because I just disallow GC while I'm in the native code. And when I come back, and there's no blocking requirement there, that's fine. If you're not calling code that'll ever block because you're not a stupid Java thing that says that the synchronized native calls can be synchronized, then you don't have to lock on entry. If you love your calling convention that your native code uses, you don't have to switch calling conventions from your JITted code. What was the other thing? Oh, handleizing. Yeah, and if you're using a conservative collector, you don't have to handleize it. So there's a bunch of things you do to make the calls off to native code like zero cost, up to 30 to 50 clocks for all the defensive things that are going on for Java calling off, whatever.
So with all that work, what is the smallest amount of native code that's actually worth calling if you want to perform it?
Well, I just told you the overhead. So as soon as you hit roughly double, you're at the point where it's not worth it. Right. So I certainly had an app come around that was somebody called the Linux currentTimeMillis instead of Java system currentTimeMillis, which added 50 clocks plus it called currentTimeMillis, which was 30 to 50 clocks. This was a major overhead cost on their app, and they complained. And we said, fuck, use Java currentTimeMillis, for which we optimized the shit out of. And there was the US Post Office. I have no idea why they were calling currentTimeMillis on a native call, but they had a own custom version of currentTimeMillis. Fine.
I thought that Java currentTimeMillis could serialize behavior. If you had a bunch of different threads, we're all calling currentTimeMillis.
Java currentTimeMillis gives you a strange hard guarantee that's difficult to achieve. It does not per se cause serialization. It does give you a happens before relationship if your currentTimeMillis value is off by 1. It's not identical. Because real live running Java apps expect that if I call currentTimeMillis on my thread and you call currentTimeMillis on your thread, and we compare those currentTimeMillis and they're different, the guy who came after has a happens before relationship and he can trust memory this guy wrote. So one guy writes a slot of memory, gets a currentTimeMillis. One guy reads a currentTimeMillis, compares it to this guy's, sees as they're off. He then reads his memory. He expects a happens before relationship. It's a hard guarantee he gets that memory right. If your currentTimeMillis is, for instance, look at the Intel tick counter register, TSC, and shift scale add it a couple clock cycles to get a millis that's accurate within, you know, nanos or micros or whatever. You get a pretty good answer out of that. That has to be a happens before relationship. That is serialization behavior you're talking about, and that does not happen on an x86. So you can't do that. Now, the early TSC registers weren't monotonic across the core, across the cluster. Anyhow, they did clock cycle heat throttling, and they would tick faster or slower, and so you couldn't use them for ticks. They were intended for using for currentTimeMillis, you couldn't because of all kinds of throttling issues.
They fixed that in like 08 though.
They fixed it. Well, then the next one is they fixed it in a version that said it's monotonic, except it's not synchronized across the core. And then there was a version where it came synchronized across the core and everyone had the same thing. So an OS could switch you from one core to another on the same socket, and your currentTimeMillis wouldn't run backwards. So that was another one.
Great.
And then these days, I don't know if they synchronize across multiple sockets. If I have a 2-socket motherboard, can I trust TSC if the OS switches me from that socket to this socket? I don't know. Azul, you could. Azul had 16 chips with 24 cores each, and later 48 cores each, about fucking 1,000 cores. That currentTimeMillis register was synchronous across the entire box. Not so on an x86 that I know of to this day. So we don't. So the current solution is you call the Linux best effort currentTimeMillis, which reads some atomic things and writes them and then reads them again. And if they're the same, he claims that the tick didn't happen. So you have a good answer. So it requires him to read some things and read them again. And it's like, 10 to 20 clock cycles all told, because he reads a bunch of words and he reads a bunch of words again, lines them all up. Plus you have a bunch of registers used. So you spill and reload and whatever, blah, blah, blah. It comes about 10 to 20 clock cycles. That's our current best effort. You could get a 1 clock cycle version if Linux would set aside a page that was user read only, and the kernel would write to a millisecond on something whenever he updated on his own timer internally. He just wrote a new millisecond updated. The user threads would all read this page, which would cache in your L1 cache if it wasn't changed by the OS. And in one L1 cache hit, you could have the currentTimeMillis on a clock cycle that would be, have all the happens before relationships you ever wanted. So there's a way to drive it down to 1 clock or less, but right now it's 10 to 20 according to your OS and your CPU and your variant versions thereof. It's not too bad. Certainly way the hell better than taking native call and then doing the same thing, because under the hood they just called Linux currentTimeMillis, and then they unwound from the native call. That added double, triple overhead. I went down this path because in those days at Sun, trying to do spec JVM, spec JBB 2001 benchmark, a record-winning score would compute currentTimeMillis billions of times per second. So not millions, billions per second. And of course, you take a chip at that era, you couldn't do it with one chip, but you could do it with a large cluster. And half, no, quarter of your time was spent computing currentTimeMillis is something totally ludicrous. It wasn't a quarter, but it was like 10% of your time was currentTimeMillis. It was big enough number that it really made the charts. So there was a lot of work made to optimize. And then we did the TSC register hack, which then led to the flag that says -XX : plus aggressive optimizations, which would replace the good currentTimeMillis, which would break a bunch of frameworks, a bunch of Spring and JBoss, a bunch of guys broke on that one. Replace them with the TSC register because they gave you 10% on JBB. So horrific benchmarking war games from a decade ago. Like, oh my God, what do you got? 20 years ago, God knows. But yeah, I played all those games in all directions. Just stupid.
But Java doesn't come with any kind of standard call that's like thread local currentTimeMillis. I don't care if this is consistent across threads.
currentTimeNanos.
Ah, okay. And that's
exactly currentTimeNanos says, I don't give you shit for guarantees. And exactly the implementation is read the TSC register. Here you go. Maybe there's a shift scale add.
So currentTimeNanos is more efficient than currentTimeMillis.
Oh yeah. And
that is counterintuitive to me.
It is not monotonically increasing. It can run backwards. It can do all, but people do it for doing caliper-like games. All people doing low latency timing information all start with currentTimeMillis. And you have to do sanity checks. So if it ran backwards, you throw that point away. You have to do statistical analysis. You get a bunch of outliers. They're probably actually outliers are probably actually broken. Throw them away. Now you get a bell curve on your currentTimeMillis, and you can slot the middle and add a standard deviation. Say, that's a pretty good answer. And nanos, I'm sorry. And then you can reasonably measure things on a handful of clock cycles if you play the game a little carefully. You want to know what an L1 cache hit is? You want to know what an allocation costs to allocate an object and fetch a word out of it without ever writing. You can get that number. I'll tell you what, it ain't an L1 cache hit. It's not a pretty number if you stream them through. If you do one, x86 will hide it from you underneath the hood, because you'll do nano time, that'll load TSC register. You'll load, that'll totally cache miss. 300 clocks later, you'll do nano time, and then in the next clock cycle, you do nano time again. He'll diff those two, will say, 1, 2, whatever. Hey, it's only 2 nanos. Okay, the load value that you didn't use yet, that came 300 clocks later, so you didn't know the real cost. Now stream them through like a linked list kind of thing. What's that cost? Oh, that'll show you the cost. This load is super slow because it depends on that load for its address, which depending on that load, and there ain't no shortcut that x86 can do now, and now you're stuck in it. So all them games you do the currentTimeNanos if you want low, but you have to be aware that it's not monotonic. It goes backwards, skip around, whatever. OS does what it does with the cores, and the hardware does what it does with the TSC register. But it's better. Like I said with Cameron, I think it's per socket, it's monotonically increasing now.
Yeah. So the multiple sockets, they don't share the same timer, but they should be running at the timer is supposed to run at the same speed, but they're not guaranteed to get the reset at the same instruction.
Right.
So they
Zool did that guarantee, but boy, that was a bitch to get right.
I was going to say, you could probably, I'm just guessing, you could probably assume that the TSC is within 4 cycles, at least.
Right. I would claim that you would do in software a phase lock loop, and then you could come up with the relative difference between your TSCs and do the adjustment. And
that's the way we used to do it before Intel locked them on across all the cores. We used to do the ping pong.
Ping pong test thing. Yeah,
ping pong test.
Yeah. I claim
so it's
that
kind of the same thing. You could do that across sockets. Yeah.
Right. You'd have to be at the low level where you could demand threads running either in root mode, kernel mode, or in user mode, where you demand what socket everyone's running on, and then do ping pong tests for a while and do some statistical analysis. And the kernel may do that now, and he may do adjustments. If you go to system currentTimeNanos, he might give you an adjustment that might help that. I don't know. I suspect it still drifts, and maybe NTP comes along and corrects the drift occasionally. So if you're using it this way and you're trying to do math, you'll see it like sine wave. The relative variation between cores will sine wave a little bit maybe, but statistics always you trump randomness with statistics.
Yeah. Well, and you aggregate large numbers.
Aggregate large values, and that'll smooth that sucker out. Yep. Since there's only a couple nanos you're measuring, you can do a few billion of them.
Right. Well, and when you're measuring small things, most of your measures will be 0. Yeah. So you're not actually looking at the measure itself. You're looking at how often do you see non-zero measures. So in your micro benchmarking, almost everything takes 0 time. Yeah. Right. Yeah. So.
Well, okay. I will do micro. Okay, so I don't know. Maybe I call that nano benchmarking. I do micro benchmarking. I think small amounts of code, huge trip count in order to get reasonable numbers out of the timers.
Oh, right. That's the alternative. But if you're not able to be timing the loop itself, is what I'm saying.
Yeah. If you're no. Okay, fine. So you're doing nano bench. I don't have a real name here. So nano benchmarking. Fine. I get it. Yeah. Right. Yeah. You get a lot of zeros out. Yes.
It used to be really, really painful because we had a 17 millisecond minimum clock change in Intel in the 90s.
That was Windows.
That was Windows.
That was not Linux. That was Windows.
So you had 16 to 17 milliseconds. So basically, anything less than 17 milliseconds was 0.
Yeah, I lived that era. I remember.
So what you would do is you would run it millions, billions, whatever times.
Yes.
And every once in a while, one of them would be at the boundary.
Yeah.
And so it would take 17 milliseconds.
Right. But you could say you could still add them and divide.
Yes, but you had to sample a large aggregate.
You had to sample a large enough aggregate. Yeah. I did those games. And in fact, very early on, I learned the value of a standard deviation for those numbers.
And in fact, Mark Falco, who's sometime on this call, he actually wrote a blog on this sampling approach many years ago. And, but it's really handy because it turns out that the numbers actually, with a large enough sample, the numbers actually are almost perfect.
Yes, yes,
It's
yes,
amazing. So,
yes. If in fact you are,
17
Yeah, it was-
milliseconds is about 60 hertz.
yes,
Were they getting the clock off the power line?
yes.
I don't know, it's
Exactly.
Windows.
The
so
power line's not a good clock.
Just imagine the worst possible approach, and you know Microsoft was using it.
You've heard my power line. Have you? Well, not everyone here has my. Who here who don't want to hear my power line clock cycle breakage again? All right, I have to do it now.
But sometimes it runs fast and sometimes it runs slow, and it depends on the load of like the entire city.
Yes. This was me doing a laser printer in the 90s, and it had a high resolution laser sweeping. It was a very, very early laser printer before they became the de facto standard, way before that. And it had a phase lock.
So could you see in your printed piece of paper when someone turned on the blow dryer?
No, there's another trick here that you're missing. So it worked perfectly all day long, and you got great photos, pictures printed out, everything was perfect out of it. And then we'd run it overnight for load testing for reliability. And in the morning, you come in, there'd be a stack of test pages, and you thumb through the stack of test pages, and right in the middle, there'd be a fuck up. And there'd be about half an inch or some fraction of an inch of pages that had been wavy, smeared left and right. It was like the
because
paper had
midnight's
not
when the
rolled.
power company's fixing the clock.
The power company, you have heard this trick. The power company's fixing the clock. Back in that era, everyone ran induction clocks for their standard overhead clock that was a circle. I'm in an office. Those are induction motors off of an AC line. And they counted ticks from the clock frequency. And the clock frequency varied throughout the day. So by the end of the day, the clock was off according to however many cycles you were plus or minus according to load in the city during the day. So the power company added or removed clock cycles to brought you in sync with a perfect time, from the Naval Observatory time. And then at that time, you could watch the clocks in the room tick fast or tick slow or fucking stay in place and do a wiggly thing, but they didn't actually go. And then they started ticking forward again. It was the weirdest shit to watch. It happened at midnight in this particular town, Eagan, Michigan, Massachusetts. It was Minneapolis and St. Paul, a suburb of Minneapolis, St. Paul. And we could watch the clock do its weird ass thing at midnight every night. And that was when the paper screwed up on the printer. As soon as the lead hardware engineer, I was the lead software guy. As soon as the lead hardware engineer saw that, he was like, oh, fuck. We both knew what it was. He asked me, he's like, what the hell? And I said, look, the clock. He stared at the clock. And then we both knew. It was like, oh, God. And so immediately he ran the next day and put on a quartz chip, raised the cost of a $1,200 device by $1. Well, then it was like $20 or something. It was an interesting cost savings. You raise the cost, put in a
there's so many pieces of software out there that don't work if your clock is not monotonic. And it turns out that, system currentTimeMillis not monotonic.
That was, yeah. Sun at Sun, when we did the TSC hack, it was not monotonic, and that burned us. That was where we had to have it happen before relationship.
Right, so, but it'll still, like if you have NTP and NTP and whatever, the clock will jump backwards an hour.
If you on system currentTimeMillis, I don't know no, not unless you are weirdly whacking it. Well, let me restate that. The current implementation, as of last I checked, which I guess a little while ago, was go to the kernel and ask the kernel for their best, highest quality currentTimeMillis value. Which, as far as I know, like most folks don't run it backwards, but I guess the Linux NTP, if Linux NTP thinks you're way off, he might drift that number. I thought he slowed it way down until time caught up.
So I'm pretty sure that system currentTimeMillis, at least in the past, wasn't using a monotonic clock.
Yeah, yes, definitely.
So you could see it drift backwards and forwards and so on. But it could even jump. It could even jump on a daylight savings switch, for example, depending how you configured time zone for the machine.
Right. I claim that this was known behavior back in the late 90s, early 2000s, and it got fixed.
I had seen a fix with this when you sample the currentTimeNanos. If you compare it with the last previous timestamp, if it's smaller, you increment the current timestamp by 1, and you get
nanos
also in the near future.
Yet nanos never had any guarantees, and still to this day does not. Whereas Millis at this day, I claim it has a hard guarantee of monotonically increasing.
Get time of the day. Mm.
And now the question is, who implements current get time of day out of the Linux kernel or the Windows equivalent or the, whatever, Mac OS equivalent, right? These guys also went through zones where they go backwards or forwards according to whatever. And then we eventually got them disassociated. So you could go ask currentTimeMillis against the UTC UTC +0, blah, blah, blah. And you got the right answer every time. But there was definitely some zones where different revs of different OSs would do different games. And I know currentTimeMillis bounced around. And I know, like Cameron said, there are plenty of apps that choked and died if you went backwards. One of the cool hacks for Azul was we did a software-only emulator for the hardware. It ran, on a fastest x86 of the day, it ran much slower than what we thought we could get off of our anybody's chip. So, 20x slowdown, 10x slowdown. And because it ran 10x slower, the timeouts would happen for everybody because everyone thought that time was running 10 times slower, except occasionally people would reach out and grab the real time, and then they would be out of order with each other. So we ended up intercepting every possible thing that had a time-like stamp on it and had to fuck with them all, including file stamps and, OS, get this and that, and directory.
That's why the clock should be injected.
Yeah, it was a real pain in the neck to catch them all. There was no single point we could catch all the clock-like things and slow them all down by 10x. So that was like a learning curve for us, witnessing all these Java apps that would in fact choke and die when the timer ran backwards on them. Okay. Some of them choked, many of them choked silently. That was the sad part. They would run forever. Oh, the transaction timed out. I'll just rerun it. Oh, the transaction timed out. I just rerun it and rerun it, rerun it. Oh God. Hey, this JBoss is taking a long time to boot.
I have seen code that checked if you start the clock, return a value smaller than the previous sample, it increments it by 1. It gets the nanoseconds in the very near future.
Yep, that is a common hack people do exactly for this case what Cameron was talking about, where we're trying to sample a large enough guys. I claim the correct answer there is to throw that point away and claim that something happened and you're not measuring what you thought you were measuring. You're measuring an OS took an interrupt, you swapped cores, whatever. There was an extra overhead and an extra screw up. Toss that point.
I've certainly written code that was like, I need a transaction ID for this thing, so I'm going to use the current time, unless that's lower than the latest transaction I've ever used, in which case, one more than whatever the last was. Like,
I've totally seen that too.
I've written the go get the time or add 1. Max of time or last time plus 1.
And I've totally had guys in high frequency trading say that, yes, this is all unique and we'll just do the millisecond. And we can handle a few guys on the millisecond, but we have a 500 transaction limit at the millisecond boundary, and you can only ask for this minimum slot was 1 millisecond, but it'll never run out. And sure enough, some asshole tries to hammer this change doing, what do they call it? Not painting the tape. There's a word for the one where they try to overrun the exchange to slow it down so they can front run somewhere else. And they hand you a million order, cancel, back as fast as they can. And you get 10,000 transactions at the millisecond boundary. And this is like, hey, we're doing all kinds of analysis with but we can only get 500 on the millisecond. You ask whatever range you want, but we'll cap you at 500. I want 1 millisecond. Well, that's more than 500. Okay, how do I get the second 500 at the same millisecond? Oh, the API didn't let me do that.
So the challenge we had was in the cluster. You have timeouts as a kind of last resort for death protection. So you send a message. When do you resend it? Well, you resend it after some number of milliseconds or nanos, or whatever, right?
Yeah.
And when do you give up and declare them dead? Well, the thing is, you go to check the message and you're like, okay, I sent it an hour and 1 millisecond ago because NTP happened.
Yep.
Right. So it looks like you haven't had any responses from a server in over an hour.
Yeah.
And that can cause havoc.
So at H2O, we did a thing where we pinged you a message with enough delay that we expected a response from most cases. So it was the common case scenario. But after so much time had elapsed after we sent you the message a couple times, the guy receiving would send us a knack instead of an ACK. So ACK had the answer. He sent us a knack saying, I got your request for information. I don't have it. Now we quit sending you because you've acknowledged that you have it and you'll get to it when you get to it. And of course, it's big data. He's totally slammed and he'll get to it when he gets to it.
Yep.
But we had to
What
put
happens?
the knack in.
What happens though if you send a message and a millisecond later, you say, when did I send the message? And it says an hour ago.
We didn't get a millisecond running backwards by an hour because we were past the point in time where that ever happened with currentTimeMillis.
No, I'm sorry, right. Or you're saying you never saw that.
Yeah, never had to handle that one because we didn't have currentTimeMillis running backwards. We did demand that everybody have the same currentTimeMillis, and we checked for that at cluster startup.
Right. That's the same thing we did. We would adjust and then skew. Yeah.
Yeah, and in fact, I think we lived with an adjustment for each node.
Yeah. But yeah, time sucks.
Yeah. No doubt about it.
Because it doesn't exist.
I keep watching all these fun physics things with this, what's this lady? She's really good at explaining shit, but she's also like hammers the current thinking on physics. It's fun to watch her.
Some paradoxes. It's explained.
Here you go, Sabine Hassenfelder. She's a good listening to. It does a good job and like hammers. Yeah. Okay.
Well, she's a little bit cranky when she's like, stop trying to explain why there's more matter than antimatter. There's no reason they should be equal.
Right. It's fun. That's what I'm saying. It's fun. It's like giving shit to people. It's good. Because then there's just shit needs to be given. currentTimeMillis is not monotonic. When is this answer posted? Yeah, he posted in the 2010. I claim that's a lie. I believe it's guaranteed monotonic up to what your NTP does. Okay. If your NTP is running you backwards, then yeah.
Backwards and forwards. My point with the timeout is that forwards can be just as dangerous as backwards.
Yes, I agree. Yeah.
So you want some clock that's local that you can say, kind of elapsed time from the last time I asked you, basically.
I claim. Oh, you're claiming you even went to the place where the remote server is dead.
I just want my logs in UTC1 and not in Pacific time because Pacific time jumps forward an hour and backward an hour.
No, I agree.
So all servers should be running UTC.
Yeah, they're all using currentTimeMillis is basically the mapping from that to every UTC across the planet. It's fine. Yeah, okay. If your NTP runs you forward an hour, then you're screwed that way too. We didn't do cluster death on missing a node because we couldn't survive it. But we would log that this guy hasn't been heard from in an hour. But then suddenly he appears again and we'd be like, oh, okay, yeah, that's fine.
Yeah, I've gotten to the point where I've started thinking about time like temperature. Temperature is not a real thing. There's just lots of particles that each have a speed. And it's like, right, but the room does have a temperature. Like, time's not a real thing, just the causality of events in your systems. But lots of things are caused by lots of other things. So like there is time.
Yeah, as soon as you go multi-node, multi-cluster, you got to go to causality, not on absolute time. That was the golden thing I demanded out of the hardware guys at Azul and got for the big box was there is still a golden time. We didn't have the causality thing going on. Whereas an x86 cluster, every socket board, you had causality between nodes, but you didn't have time between them.
And they had to add hardware to do that, or?
Yeah. Oh, fucking the clock circuit on that guy was almost half the die. So, because it had huge buffering, because it had to go 4 boards away, four guys per board, 4 boards away, and get a phase lock loop going. It was a ginormous capacitor inductive circuit to get that phase lock loop going. And it ate a big chunk of die, like a big chunk of die.
And I imagine a fair chunk of power.
And I'm sorry, it ate a bunch of power too. Well, the power consumption is always cooling related. How much cooling can you ditch? We decided against water cooling, so it was air cooled. Big ass fans on that boy, loud, noisy. The fans are better these days, but back in that era, they were big. They were mainframe level quality fans with a mainframe power budget with them. It was not a low power device. Yeah. Okay, yeah, Stack Overflow. Okay, so we should probably put that Stack Overflow link in the doc, but I want to call it here at some point because we're 2 hours in and it's lunch. Oh, is the doc the thing making here? Let me just
You're gonna call it because you believe in time.
boy, links everywhere. Yeah, fine. All right. Who's doing this? Is this TD or is that you?
Which one? The time?
Hacking in the doc. Whoever's hacking in the doc, however
Yeah.
many you are, thank you very much.
It's a collaborative effort.
It's a collaborative effort. Good. It's not me.
I write the timestamps. Somebody corrects the timestamps. Adds somebody adds the links. That's what it's for.
Yeah, JVM does that. Yeah, that's the hack on what the hell you do with the JVM. And slides 21. Oh, you even got the slide numbers in there. Yeah, let me go pull that one up. See, this is the 21 here.
Hey, Cliff.
Yeah, there it is.
Are these docs, do you publish them also when you publish the video? Because I didn't see a link like from the old videos to an old doc.
The old videos, no. After I started doing doc.new, this is like Tior put me on this a couple months ago. They're in there, yeah. The YouTube channel I dump the hard chat, which only if there's something exciting in it. I dump the doc link. I dump the time breakdown, timestamp breakdown, and that's it.
Okay, so it's under the actually I've been just searching
Comments.
YouTube. Is there some place?
It's in the YouTube comments.
In the YouTube comments. Okay, I'll look there.
And then just another comment section, the description for the video.
Yeah.
There's a title line, there's a description. Description says, hey, CCC of this date. It's all cut and paste mechanical from the last go around. Private, whatever, unique link.
Also, probably a good idea to turn off comments and edits before you put those in the YouTube video.
And I do. I try to make a doc.
He does.
Yeah. Oh, you were trying to change one once.
Those timestamps in YouTube videos are pretty helpful. So I've been watching old videos and kind of going from timestamps.
That's why, folks, we have to include a few when the recording started at the top, so you can subtract if you add the timing. So it's the correct offset when it's uploaded to YouTube.
Yeah. All right, folks. Any last comments before? Merry Christmas. Happy New Year. I'll claim we're on again next week. Whoever wants to show, we'll make it go again. See who's sane or not sane at this hour for New Year's.
It will be 31st, the next Friday.
It's actually 1:44 a.m. here in India.
Yeah.
I'm still wake up for this. So sometimes I'm not able to join this club. So I just go to your YouTube channel and I rewatch the videos.
Yeah, no problem.
Thank you.
Yep.
We're happy to have you.
All right. Till we meet again.
Okay, bye.
Bye.
Merry Christmas.